So good day sir, good day classmates. So we are the group 7. I am Decadet Ortega, Cirilo Jr. And here is my group mate, Decadet Aponda Joshua, Decadet Paulican Warren. So our topic for today is about refresher on radar. So our intended learning outcomes is to perform manual plotting techniques given the information from the radar observations. The student should be able to perform these refresher exercises and must have basic competency on radar plotting. So, the USCG requires that radar observer certification be renewed every 5 years. So, since modern electronics are so agile, many mariners have not done an actual radar on those 5 years intervals. So, to brush up, here is a quick refresher on plotting procedure. So, we will begin with vector triangle. As in the case, with all triangles, this one has 3 sides. So side from E to R represents the true course, direction, and speed, length of our vessel. Side E to M represents the true course and speed of other vessels. So lastly, side R to M represents the relative motion vector, the direction and speed of the other vessels' apparent movement. Letter E is an anchored in the plot. M, may, and R certainly will be relocated, but E does not move. So next terminology, what is CPA? So CPA is a closest point of approach. So if the line of relative motion is extended, the CPA, the shortest distance from that line to the center of the plotting sheet. So if the CPA is 0, we are on a collision course with other vessel. Next, RML, or also called as relative motion line. In RML, new relative motion line. SRM, speed of relative motion, or length of R to M. DRM, direction of relative motion, or direction from R to M. MX, so the position of other ship in RML at planned time invasive action, point of execution. So radar plotting used to be preferred to as rapid plotting with an emphasis on rapid in order to make procedures quick and mathematically painless. Contact are usually observed at intervals of 6 minutes, 12 minutes, or even 15 minutes. So calculating speeds or distances is extremely easy as this is several for examples. So if a vessel is traveling 18.2 knots, that is 18.2 nautical miles per hour. So she will travel 1 to 10 of that speed. So 1.82 miles in 6 minutes. If a vessel has traveled 1.2 miles in 6 minutes, her speed is 10 times than, so that is 12 knots. So the table below shows the distances traveled in 6 minute, 12 minute intervals at a speed of 15 knots. So we'll work a standard of 6-minute plot step by step. So we have a ship course 345 degrees, speed is 15.0 knots. Note the following contact. At 0830, the contact bears 39 degrees at a range of 9.0 miles. At 0836, the same contact bears 326 degrees at a range of 6.0 miles. So we will be calculating about the CPA, contact's relative speed, contact's true speed. When the range to the contact drops to 4.5 miles, you want to change course. So step 1, notice that plot is a 6-minute plot. So speeds, distances, and time will be based on a factor of 1/10 using maneuvering board or radar transfer plotting sheet. Draw a line from the center of our ship in direction the vessel is heading. So we have this maneuvering board or the radar plotting sheet to cover up distances and speed of vessels from other vessels. So this will be discussed by my teammate Decadet Warren Paulican.
Step 2. Plot the first observation at 0830 hotel contact using the 1:1 scale. It means the 10 concentric circles on a maneuvering board each represent as 1 mile in length at a bearing of 329 degrees and a range of 9 miles. Then label it as R. So as you can see on the maneuvering board, the first observation is plotted at 9 miles at 329 degrees and marked as R0 0.830. Step 3. Locate E on the plot. Set the dividers for the distance of our vessel will travel in the interval of the plot. In this case, 6 minutes at a speed of 15 knots is 1.5 miles, parallel to the course line 345 degrees over to R, and draw it in backwards away from R. Remember, the course is from E to R. Level this position E. So we can see the result on the maneuvering board. E is drawn backwards away from R, which is parallel to the course line with a distance of 1.5 miles. Next, step 4. Locate M, which is bearing 326 degrees at a range of 6 miles at 836 Hotel. Now, it is possible to finish the triangle and solve for the other vessel's course and speed by connecting E to M, which is approximately 146 degrees at 16 knots. So we can see the result on the maneuvering board. The second observation at 6 minutes interval marked as M, which is plotted with a bearing of 326 degrees at a range of 6 miles. Next, step 5. Look at the maneuvering board below. The line drawn from R through M and past the center of the maneuvering board is called the relative motion, or the RML. The distance from the center of the plot, our vessel, to the closest point a perpendicular on the RML is the CPA, or the closest point of approach. In this case, the CPA is about 1 mile. Measure the length of R to M to find the contact's relative speed. Here, it is approximately 30 knots. Next, step 6. According to the problem, when the range to the contact drops to 4.5 miles, we are to change course so that the contact will pass on our port side with a CPA of 2 miles. The next step then is to mark the RML, the point at which the contact reaches the range of 4.5 miles from us at the center. Look at the maneuvering board below. Label this point MX. From MX, draw a line tangent to the 2-mile circle. When we change this course, this will be the new RML or NRML. Next, step 7. Parallel the NRML from MX to M. Draw the parallel line away from M. So we can see on the maneuvering board, there is a line drawn from M upwards which is parallel to the NRML. Next, we are going to change our course but maintain our speed. Place one leg of the dividers on E and the other place on R. Swing the dividers so that the R leg crosses the NRML. So look at the maneuvering board below. The point of intersection is labeled as R1. The direction from E to R1 represents our vessel's new course. To identify the vessel's new course, use the triangle rulers, then bring the E to R1 line parallel to the center of the maneuvering board. In this case, the new course is approximately 12 degrees.
Plots generally allow reasonable tolerances for answers, hence they are approximately used throughout this explanation. So the finished plot for the following problem is on the next page. Your ship is on course 245 degrees, speed is 18 knots. You note the following radar contact. At 0443, the contact bears 277 degrees at a range of 8.5 miles. At 0455, the same contact bears 270 degrees at range of 4.7 miles. So we aim to answer the following questions. So since this is a 12-minute plot, so speeds are divided or multiplied by 5. The original CPA is about 1.3 miles. The contact's course is approximately 170 degrees. The contact's true speed is approximately 13.5 knots. So to find MX, note that this is a 12-minute plot, and since 0458 is 3 minutes from the 0455 position of M, and since 3 minutes is 1/4 of 12, eyeball the distance to MX as about 1/4 the length of R to M. So when the NRML is parallel back to M and the dividers with one leg at E swung to find R1, the shape's new course is found to be approximately 263 degrees. Since the problem now says that a course change is not possible, the other option is to find R2 along with the original E to R line at the point it intersects with the RM and L. So if the vessel maintains its original course of 245 degrees but reduces her speed from 18 to 30 knots, the other vessel will cross her bow at CPA of 2 miles. And for the final example, we'll do a 15-minute plot. So as 15 minutes is 1/4 hour, we'll be dividing or multiplying by 4. So your ship is on course 020 degrees, speed is 7 knots. You note the following radar contact at 0700, the contact bears 090 degrees at range of 10 miles. At 0715, the same contact bears 090 degrees at range of 8 miles. Again, we aim to answer the following questions. What will be the CPA? What is the contact's true course? What is the contact's true speed? At 0730, you decide to change the course to 060 degrees. What will be the new CPA? What will be the time of the new CPA? So, the CPA is 0, since it has a constant bearing decreasing range. Rule 7 of the rules of the road. The contact's true course is approximately 320 degrees. The contact's true speed is approximately 8.8 knots. MX is 15 minutes beyond the 715 M on the RML, which is to say with one leg of the divider's position at R and the pivot leg at M, one swing of that span down the RML, and the new CPA is approximately 1.5 miles. The time of the new CPA is approximately 0759, almost but not quite 2 swings the length of the RML and MX. So here are the things that can go wrong on a radar plot. There are a few common mistakes to watch out for when doing a radar plot. First, make sure to draw an E to R line, not R to E line. It's very easy to draw the course line in backwards. 2. Double check the plot intervals. Working a 12-minute plot as a 6-minute won't work. Third, make sure that any cursor speed adjustments are made in the triangle. MX is not part of the triangle. The line drawn from MX must be parallel back to M in the original triangle. Always thinker in the triangle. Fourth and lastly, remember that in determining times after MX, time calculations must be made on the basis of length of R1 to M. So that will be all for our report. I hope you have enjoyed our refresher topic on radar plotting.